Could Proxima B be another Earth-like planet? These are speculations everyone keeps making. The search for an alternative habitable planet and alien life on other planets is something that fascinates humans. There have been various speculations, and the fact that signals have been detected coming from Proxima B makes people believe there is more to it. Despite all these signs, we have yet to determine if these are messages from the planet or just echoes of our own signals. Often, these signals end up as echoes. To find out whether these signals are truly from Proxima B, scientists hope to determine if alien life exists. Recently, the James Webb Telescope detected artificial lights on Proxima B. If you're interested in learning about other planets and our progress in finding alternative life, subscribe to our channel. We create content about outer space and discuss innovations in science. If you like this content, comment below and share this video with your friends. Now, let's dive back into our video. Proxima Centauri, about 4.2 light-years from our solar system, is a faint dwarf star classified as GZ. This star is known as Proxima Centauri and is the closest to our Sun and solar system. It was named Alpha Centauri by Johann Bayer in 1603. The name came from the star's ascension at noon while several celestial bodies, like the Moon and the Sun, were in a straight line. Proxima Centauri is also known as Alpha Centauri or Alpha Centauri A. It is a single star system with 4 main stars in alignment, with Proxima Centauri at the center. Apart from the 4 stars, there are 2 faint dwarfs, Alpha Centauri B and Alpha Centauri C. These make up the bulk of the mass but are too faint to be seen by the naked eye. The system is located 23 degrees away from the border of the famous Plough asterism in the constellation of Centaurus. Even though Proxima B is a rocky planet, there is still hope that it might have extraterrestrial life. The search for any life out there has brought scientists to Proxima B. They believe the similarities in size to Earth and the distance from its dwarf star make it a viable option for accommodating life. While all these are speculations, there's hope that there might be some truth. There is much to learn about Proxima B and the orbit it takes, so stay tuned and check out some of our other content related to extraterrestrials. Do you really believe there's other life out there? Leave a comment down below. What fascinates most people about Proxima B is its similarity to Earth. Studies show that Proxima B is an exoplanet that orbits an M-type star. Its mass is considered to be 1.27 times that of Earth, and it takes 11.5 days to complete an orbit around its star. Discovered in 2016, many scientists are looking into it. Even though Proxima B looks similar to Earth, certain features make it uninhabitable. For one, the planet is too close to its star, resulting in extreme ultraviolet radiation. It is estimated that this radiation is hundreds of times more intense than what we receive from the Sun. The radiation is so strong that it strips away even the lightest hydrogen molecules, and over time, it does the same to oxygen and nitrogen. While many argue that Proxima B should be habitable because it is at a similar distance from its star as Earth is from the Sun, there is more to consider. Distance does not account for whether there is water on the planet, and there is no evidence of an atmosphere conducive to living things. The atmosphere on Earth is what makes it habitable, unlike Mars. A suitable atmosphere is essential for climate regulation and a water-friendly surface, and it also shields living organisms from hazardous space weather. If you're with us so far and haven't subscribed yet, take a moment to hit the subscribe button. It makes it easier for us to keep creating content that you'll love. Now let's look at why people think the James Webb Telescope will help us figure out if there is life on Proxima B. Launched in 2018 after several delays, the James Webb Telescope was designed to observe infrared light. If a planet like Proxima B can absorb light from its star, it could also re-emit that light as infrared. The James Webb Telescope can take photos of this light on the surface of a planet and look for patterns that might confirm if the planet has water or an atmosphere. One reason space telescopes are preferred over ground-based ones is that they are above the atmosphere, allowing for clearer views of deep space without interference from shifting air. Weather changes on Earth do not affect them, ensuring a consistent reading. However, fixing a space telescope is expensive. If something goes wrong, it often requires a costly mission to repair it. Since the James Webb Telescope is over 1.5 million kilometers away, rescue missions are not an option. The James Webb Telescope has a larger mirror, enabling us to see back to the beginning of the universe, nearly 13.7 billion years ago. The further away an object is, the further back in time we can see it, as it takes time for light to travel from that object to us. The ability to observe the universe in longer wavelengths of infrared light allows us to see distant galaxies with greater certainty than ever before, making the study of planets like Proxima B easier. Researchers Tabor and Loeb have developed a scale of artificial illumination, comparing how the sun illuminates and reflects on the day side of the planet. At 0% on the scale, the night side of the planet would be completely dark, while at 100%, the night side would be as bright as the day side. Hypothetically, if there were a civilization on Proxima B using artificial light, most scientists believe it would resemble early Earth. Studies suggest that if the night side of Proxima B reaches an illumination of 5% of the natural day side, the James Webb Telescope could detect the artificial light by 85%. If the illumination reached 9%, the telescope could detect up to 95%. Even though 5% illumination sounds small, it is significant given the distance from Proxima Centauri compared to our Sun, which is 20,000 times dimmer. This means that at 0.1% of illumination, we are still reflecting some stellar light. In other words, if Proxima B has a civilization glowing like Earth, the James Webb Telescope might not detect it unless the stars were about 500 times brighter, an unlikely scenario given Proxima B's close orbit to its host star. It is possible that Proxima B might be tidally locked, meaning one side always faces the star while the other remains in perpetual night. A civilization on such a planet might need to focus on illuminating their infrastructure and using bright orbital mirrors to reflect sunlight from the day side to the night side. All these are speculations made by Tabor and Loeb, and there is yet to be proof to show that they are true. Earth's illumination can be seen from outer space and is known as airglow. Many wonder why the Earth is surrounded by bright shades of red, yellow, green, and purple light when viewed from 300 miles above its surface. Airglow occurs when atoms and molecules in the upper atmosphere produce light to release excess energy, similar to auroras driven by high-energy particles from the solar wind. Airglow is influenced daily by solar radiation. Since the James Webb Telescope's launch, scientists have been asking whether it is sufficient to view other planets in distant galaxies. Despite being the furthest satellite telescope launched, it still provides limited data needed to find planets with life in other galaxies. This has led to discussions about developing bigger and better telescopes. Such ventures are often costly and involve trial and error. The James Webb Space Telescope launch was 5 years late due to these issues. Therefore, it is challenging for scientists to develop better innovations for future launches. Despite this, the James Webb Space Telescope results are promising. Soon, we might know if there is life on Proxima B and other planets. While work is ongoing for more telescopes, the completion and launch of the Habitable Exoplanet Observatory, HABEX, is anticipated to revolutionize space study. The estimated completion time for HABEX is 2035, with a launch soon after. HABEX will be sensitive to all planets in the universe and aims primarily to search for Earth-like planets. Its advanced technology will enable it to measure the spectra of most planets and determine their habitability. HABEX is also expected to have a broad range of astrophysical capabilities, enabling it to study the earliest times in the universe's history and understand the life cycles and deaths of massive stars, as well as the elements that support life as we know it. Although still in manufacturing, the technology behind HABEX will allow it to study Earth-like planets at an excellent resolution, providing incredibly clear images. It will be sensitive to ultraviolet, near-infrared, and optical photons. The concept behind HABEX is compelling and could change space study significantly. If successfully implemented, it will enable more in-depth exploration of extraterrestrial life on other planets and offer a better understanding of Earth's history, including climate changes before human civilization. The LUVIUS idea represents a smaller version of a telescope but builds on the experiences gained from the James Webb Space Telescope. It has ultraviolet capabilities and is considered the next observatory telescope to be widely used by astronomers. Plans to launch LUVIUS simultaneously with HABEX are underway. The Large UV Optical Earth Surveyor, LUVIUS, will greatly enhance space study. Studies with LUVIUS suggest it will help understand what makes Earth distinct. Observations of 28 Earth-like planets have produced promising results. With the advancements in telescopes and the details about planets like Proxima B, visibility can improve significantly. Even though the James Webb Space Telescope has made great strides in revealing new details about Proxima B, there is still much to be done. Better visibility and the ability to analyze atmospheres differently are essential to answering whether extraterrestrial life exists. This also provides deep insights into the planet's history and the changes that have occurred over the years. Ever wonder what would happen if we discovered extraterrestrial life? Worry not. We have videos on our channel discussing this and more. Subscribe and hit the notification button to get notified whenever we post new content. Is there life outside of planet Earth? The conversation about life on other planets has been ongoing for some time. Most people believe that we are not alone in the galaxy. Various theories and claims have persisted over the years. Whether we discover life on other planets depends largely on the research we conduct. For this reason, scientists are working on ensuring more powerful space telescopes orbiting the Earth and other planets. However, these telescopes need to go beyond infrared lighting to provide better answers regarding different planetary life. For now, we watch with bated breath as we hope to see if our brother planet Proxima B has any life on it. If you love content like this and want to know more about the James Webb Space Telescope and Proxima B, be sure to stay tuned. Proxima B's location in the habitable zone of its star raises intriguing possibilities. This zone, often referred to as the Goldilocks zone, is where conditions might be just right for liquid water to exist, neither too hot nor too cold. The idea that Proxima B could harbor water, despite its challenging environment, is a focal point for scientists. Water is considered essential for life as we know it, so understanding its potential presence on Proxima B is crucial. In recent years, the advent of new technologies has allowed astronomers to better analyze exoplanets. For example, spectrometry, a technique used to determine the composition of light from distant objects, can provide insights into a planet's atmosphere. By studying the light spectra, scientists can identify the presence of gases like oxygen, methane, and carbon dioxide, which are indicators of potential biological processes. The unique characteristics of Proxima B also pique the interest of astrobiologists. Its proximity to Proxima Centauri, an M-type star, means it experiences different stellar activity compared to planets orbiting G-type stars like our Sun. M-type stars are known for their frequent flares, which can bathe nearby planets in radiation. Understanding how Proxima B's atmosphere interacts with such stellar phenomena is vital to assessing its habitability. Another aspect of Proxima B that captures attention is its orbital dynamics. If Proxima B is indeed tidally locked, it would result in extreme temperature variations between its day and night sides. This could lead to unique weather patterns and possibly even diverse ecological zones. For instance, the day side may be too hot for life as we know it, while the night side could develop a more temperate climate where life might thrive. Researchers are also considering the potential for extremophiles, organisms that can survive in extreme conditions, on Proxima B. If life exists, it may not resemble Earth's life forms. Instead, it could be akin to extremophiles found in Earth's most inhospitable environments, such as deep-sea hydrothermal vents or acidic lakes. These organisms adapt to extreme heat, pressure, or acidity, suggesting that life could find a way to exist under Proxima B's harsh conditions. Exploration of Proxima B's atmosphere is a primary goal for upcoming missions. Future telescopes like the European Space Agency's Ariel mission are expected to study the atmospheres of various exoplanets, including those in the vicinity of Proxima Centauri. Ariel aims to analyze the composition, structure, and dynamics of exoplanetary atmospheres, potentially shedding light on the conditions that might support life. The search for biosignatures, indicators of past or present life, remains a top priority. Scientists are particularly interested in detecting chemicals that could point to biological activity. For example, the simultaneous presence of methane and oxygen in an atmosphere could suggest biological processes at work, as these gases tend to react with each other and would not typically coexist in significant quantities without ongoing replenishment. In addition to the scientific endeavors, public interest in the search for life beyond Earth has never been higher. Documentaries, books, and online content have fueled curiosity about the universe and our place within it. As a result, the pursuit of knowledge about Proxima B and other exoplanets has become a cultural phenomenon, inspiring a new generation of scientists, engineers, and enthusiasts. Furthermore, international collaboration has become increasingly important in this field. Countries across the globe are pooling resources and knowledge to develop advanced technologies for exploring distant worlds. This collaborative spirit is crucial for addressing the complex challenges that arise in space exploration. Proxima B also serves as a test case for how we approach planetary protection. The protocols in place to prevent contamination of other worlds must be carefully considered as we send missions to study potentially habitable exoplanets. Ensuring that we do not introduce Earth-based microbes to these environments is essential to preserving their integrity. As we continue to push the boundaries of our understanding, Proxima B remains a tantalizing target in the quest for extraterrestrial life. Each new discovery brings us closer to answering age-old questions about the existence of life beyond our planet, while also enhancing our understanding of the universe and our place within it. In conclusion, the exploration of Proxima B encapsulates humanity's enduring curiosity and desire to connect with the cosmos. As technology advances and our understanding deepens, the potential for discovering life, whether similar or vastly different from our own, continues to inspire and excite.